Hello everyone, my name is Aschidulas. Today let's do a buffer overflow attack. A buffer overflow attack is a security vulnerability. When an attacker sends more data than a program expects, causing it to override adjacent memory with malicious code to hijack the execution. Now let's see the program. Now when we run the function buffer input this C code, the computer sends us a private workspace in the RAM calls as stack frame. Inside this workspace the computer puts three things in a specific order. First one is the buffer, and the second one is the RBP, and the third one is the return address. Now let's see what is the buffer. The buffer is just like a storage box for your text. This is the buffer, this is the storage box for your text, and the next one is the RBP, the base pointer, a helper that keeps the stack organized, and that lastly is the return address. The return address, the most important part, is the exit door coordinates that tell the CPU where to go back when the function is finished. And now let's see the vulnerability, the limitless function. In the C code, we use the gets function. It is a blind. It will take as much as data you get it. And it's like a water hose that never turns off. If you try to put 20 liters of water into a 5 liter bucket, the water doesn't just disappear. It spills over into the floor, just like a example for the buffer overflow. And next let's do the attack, the overwriting process, the spill. This is where the attack happens in this exploit.py Python file. When we send our Python payload, we send more than 64 data. This is a payload. We created a payload and we send the 64 of characters. Now let's characters 1 to 64, this fill the buffer. Okay, it adjust with the size. And now character 65 to 70, this spill out, which is like the example for buffer flow. Means we kept a size of 64, and that it holds just for a 1 to 64. But if we put after the 64 values, this spill over and override the RBP. And next for character 73 to 80, this spill even further. Means the spilling of the characters were more and land directly to the red address, which is like the exit door. Now let's say the hijack. When the C code reaches to the end of the buffer input, means when it reaches to the end of this buffer input function, it says, okay, I'm done. Let me check that address to where I should go out. Means it needs to go out of the loop to return an address. It looks at the memory, but instead of seeing the way home, here it looks at the memory. It sees the address we injected. The CPU doesn't know it's being hijacked. It just follows the instructions it sees. It jumps to the secret function, and that it is how successfully redirect the execution. And let's go to the summary of the this normal run. When input is small, memory is safer. Program returns to main function. Attack run. Input is used, memory overflows, and return address is changed and program jumps to the secret function. And the fix for this is we replace the gets function with the fgets, which says I have only a 64 byte bucket, so I have only to take 64 bytes of water no matter of what. This is what the buffer overflow program is. In this vulnerability, see exploit.py, simulator.py. This is the output of the program. Let's see stack state before attack, normal program, and this is a no nothing problem. But when we after attack, memory was overwritten. See here buffer saved RBP and the return address, and the exploit is successful. So this is what the buffer. And thank you.